This video is about solving exponential and logarithmic equations. But let's review a few key points. If the variable is in the exponent, then you're thinking of taking the log or the ln of the problem, okay, in order to find that variable. Also, remember that if the equation has e in it, then for sure you're going to take the ln of it, all right? Also remember that if you do not see a base in the question, the base is 10, and in such case, if you have the log of something equal to the log of something else without a base, then you're going to put a 10 on it as base 10, then you're going to drop the log and equate the argument, okay? So let's look at some examples here. Example 1, we have 625 raised to the 3x equals 125 raised to the x plus 1. Again, we're going to take the log of both sides because the variable is in the exponent, okay? So this would be log of 625 raised to the 3x equals log of 125 raised to the x plus 1, okay? Now remember that when you take the log, the exponent is going to be taken to the front here, okay? So let's rewrite that part here. So this would give us 3x log 625 equals x plus 1 log 125. Now in this case, you could divide both sides by log 625, or you could divide both sides by log 125. It doesn't matter, okay? Let's divide both sides by log 625. Log 625. Now this log 625 will cancel that log 625. So what we have now is 3x equals x plus 1, and let's find out what is the value of log 125 divided by log 625. Okay, so here we go. Log 125 divided by log 625, and that is 0.75. So this is times 0.75. Okay, so what we have now is 3x equals 0.75. You're going to use that to distribute into the parentheses. So 0.75 times x, that is 0.75x, plus 0.75 times 1, that is 0.75. Okay? Now we want all the x's to be on the same side, so we could subtract 0.75x from both sides. Alright? And that will now give us 3 minus 0.75x, 3x minus 0.75x, that is 2.25x. So that is 2.25x. That part will cancel, and that is just equal to 0.75. Then we're going to divide both sides by 2.25. So x is equal to, let's see what that is, 0.75 divided by 2.25. So 0.333, that is the same thing as 1/3. Okay, so x equals 1/3. And it's better to write the fraction of it, that will give you the exact value. Now we can prove this thing. Okay, let's prove it. So the question says 625 raised to the 3x, but we just found out that x is 1/3. Okay, x is 1/3, so that is 1/3 here. 3 times 1/3 is just 1. Okay, you have 1/3, 2/3, 3/3. 3/3 is the same thing as 3/3, which is 1. Okay, so this is just 625 raised to the 1, which is just 625. Okay, now let's find out what is this side here. This side says 125 raised to the x plus 1, but our x is 1/3. So this is 125 raised to the 1/3 plus 1, which is, remember, 1 is the same thing as 3/3. So 3/3 plus 1 more third, that is 4/3. Okay? And if you go back to your knowledge of exponent, remember the denominator tell which root you're taking. So you take it, because the denominator is 3, you're taking the third root. And whatever you get, you're going to raise it to the numerator, which is 4. So let's do that. This is saying you're taking the third root of 125, And then whatever you get there, you're going to raise it to the fourth there. So let's do that thing. So we hit math, and we scroll down to number 4, which is the third root of 125, and that is 5. Then we're going to raise that 5 now to the 4. Okay? And there we get our 625 just the same. So both sides say the same. So we have proven that part there. Okay? Now let's look at example 2. Example 2 says e to the b minus 3 equals 6. Remember we discussed in the notes a few minutes ago that once e is in the question, we're going to take the ln of it. Okay? So we're going to take ln of both sides. So this would be ln e raised to the b minus 3 equals ln 6. Okay? Again, all of this exponent here is going to come to the front. So all of this is going to come to the front here. So what you would have now is b minus 3 ln e equals ln 6. But remember that ln e equals 1. So 1 times all of this b minus 3 is just b minus 3 equals ln 6. ln 6 is an actual number. Now the actual value of this thing is to leave it at ln 6. So you could go ahead and add 3 to both sides. So b would equal to ln 6 plus 3. But if we want an approximated value, we can also find that. So let's take it from right here. So b minus 3 equals ln 6 plus 3. Let's find what is ln 6. So ln 6, we hit ln and then 6, and that is 1.79175 whatever. Okay, let's keep it to 2 decimal places. So we're going to have that as approximately 1.79. So this would be b minus 3 equal, well, approximately 1.79. Then of course you would add 3 to both sides. So b would just be 4.79. Okay, and we could also prove this thing. Let's prove it. So we know that b is 4.79. Okay, that's approximately 4.79. So this would be e raised to the 4.79 minus 3. And let's see if that will equal to 6. Okay, so this would be e, let's see now, 4.79 minus 3 is 1.79. So that is e raised to the 1.79. Let's see if that is equal to 6 or close to 6, since it's an approximation. So it is e. Here's e on your calculator. So to get your e, you hit second and then the ln button, and you get your e raised to the 1.79. And of course, you see that is almost 6. And why we didn't get the full 6, if we had used the full value that we got for our ln 6, then we would get the exact 6 here. But if we round this to the nearest whole number, you see we get the 6. Okay? And that's how we prove that kind of thing there. Okay, let's move to our final example. Our final example here is negative 5 log 3m base 8 equals 5. Again, as we discussed in previous lessons, that when you're solving logarithmic equations, you're solving it like normal equation. And so if something is added or subtracted, you're dealing with those first. And then whatever is multiplied or divided, you're going to deal with those next. So in this case, we see that our log 3m base 8 has been multiplied by negative 5. So to get rid of that, we divide both sides by negative 5. And this would be log 3m base 8 equals negative 1. Now this is going to bring us to the exponent law of logarithm, which says that this base will be the base on this side as well. And this number over here will be the exponent for this base. Okay, so what we would have now, and we will drop the log. So what we will have is the 3m equals to 8 raised to the negative 1. Okay, remember that 8 raised to the negative 1, 8 raised to the negative 1 is the same as 1 over 8. Okay? So what we would have is 3m equals 1 over 8, and we divide both sides by 3. So I divide this thing here by 3 as well. So m is equal to 1 8 divided by 3 over 1. Remember, keep, change, flip. So this would be m equals 1 8 times, then you flip this thing now, that is 1/3. So m is equal to 1 over 24. Okay? 1 over 24. And again, we can prove this thing here. We can prove it. So negative 5 log 3 1 over 24 base 8 equals 5. Okay? So this would be negative 5 equals 3 times 1 over 24. That would be 3 over 24, which is the same thing as 1 8. This would be log right here. Base 8 equals 5. Again, if we divide both sides by negative 5, we would have log 1 8 base 8 equals negative 1. Okay? And again, this would be 1 8 equals negative 1. It would be 8 raised to the negative 1. And remember that 8 raised to the negative 1 is the same thing as 1 upon 8. So this is just 1 upon 8 equals 1 upon 8. And that's the proof of it. Okay? Alright, I hope this should help you with whatever log or exponential questions you have.